Hey everybody, today we will be investigating the main transformations of trigonometric functions. In particular, those with sine, cos and tan. Firstly, all the transformations which can occur in general to any function and can specifically be applied to trigonometric functions can be summarized by four types, which include vertical translations, horizontal translations, vertical dilations, and horizontal dilations. So these are the four main types of transformations you will encounter. A vertical translation is when the graph is shifted upwards or downwards. The general form for a vertical translation is y equals f of x plus c. So this is a vertical translation, in which if c is positive, the graph shifts upwards by c amounts. However, if c is negative, the graph shifts downwards by c amounts. This transformation changes the y values of the function, affecting range. The C represents the center of sine, cos, or tan functions in relation to trigonometric functions. Furthermore, a horizontal translation is when the graph is shifted to the left or to the right. The general form for a horizontal translation is y equals f brackets x plus b close brackets, in which if b is positive, the graph shifts left by b amounts. However, if b is negative, the graph shifts right by b amounts. So b is your horizontal translation in this equation. This transformation changes the x values of the function, affecting domain. In relation to trigonometric functions, the b represents the phase of the sine, cos or tan function. To continue, a vertical dilation is when the graph is stretched or compressed in the direction of the y-axis. The general form for a vertical dilation is y equals k f of x, where k is your vertical dilation, in which if k is greater than 1, the graph is stretched by a scale factor of k. However, if k is in between 0 and 1, the graph is compressed by a scale factor of k. This transformation changes the y values of the function, affecting range. A special case of a vertical dilation is a reflection in the x-axis, which is represented as y equals negative f of x. So reflection in the x-axis can be represented as y equals negative f of x. It can be observed that this is a vertical dilation with a scale factor of k equals negative 1, hence the negative outside of the f of x. In relation to trigonometric functions, the k represents the amplitude of the sine and cos functions. It is also important to know that the tan function has no amplitude. Finally, a horizontal dilation is when the graph is stretched or compressed in the direction of the x-axis. The general form for a horizontal dilation is y equals f brackets a of x, where a represents horizontal dilation, in which if a is greater than 1, the graph is compressed by a scale factor of 1 on a. However, if a is in between 0 to 1, the graph is stretched by a scale factor of 1 on a. This transformation changes the x values of the function, affecting domain. A special case of a horizontal dilation is a reflection in the y-axis, which is represented as y equals f brackets negative x, where a is negative 1. It can be observed with a negative sign right there. Also, it can be further observed that this is a horizontal dilation with a scale factor of a equals 1 on negative 1, which is equal to negative 1. In relation to trigonometric functions, the a represents the period of the sine, cos or tan function. Specifically, y equals sine ax has a period of equal to 2 pi on a, y equals cos of ax has a period of 2 pi on a, and y equals tan of a on x has a period of pi on a. In summary, the combined transformations of trigonometric functions can be modelled as y equals k sine brackets a brackets ax plus b brackets plus c, that's for sine. For cos, very similar, k cos brackets a brackets x plus b brackets plus c. And for tan, y equals k tan brackets a brackets x plus b brackets plus c. So this is how you can model all three trigonometric functions regarding each transformation, where the k is a vertical dilation, the a is a horizontal dilation, the c is a vertical translation, and the b is a horizontal translation. It is important to know that the order to perform the transformations is important. Firstly, we must perform the horizontal dilation. Then, the horizontal translation. This is followed by the vertical dilation, and finally the vertical translation. Let's now put what we have learned into practice with an example. So the practice example we have here is state the transformations taking place for the function y equals 4 sine x over 2 plus 1. Firstly, we can recognize the function has an amplitude of 4. So k is equal to 4. That's the first transformation of vertical dilation, as well as it has a center of 1, which is our vertical translation. C is equal to 1. This means the minimum value of the function is our center takeaway. Our amplitude, which is 3, that's our minimum value for the function. And our maximum value of the function is our center plus our amplitude, which is equal to 5. That's our max value for the function. Since this function is a sine function, we can also recognize its period can be found as 2 pi on a, which means our horizontal dilation represented by a can be given as 2 pi on a. Therefore, this results in 2 pi on 0.5 because our a value for this function is 0.5. Therefore, the period is 4 pi. Also, there is no phase shift, therefore no horizontal translation taking place. So these are the transformations that take place: k equal to 4, c equal to 1, and a equal to 4 pi. I hope you have gained a solid understanding of transformations of trigonometric functions. Thanks for watching. I hope you have an amazing 2022. See you later.